Okay, so now we're going to look at some problems that deal with translations on some of our 9 famous functions. Okay. So there's a few different types of questions that we're going to go through. So the first type of problem, we are given a graph. And then we're going to ask 3 questions here to identify the basic graph, describe in words the shift that occurs, and then write the function of the given graph. Okay. So looking at the first one, you should recognize this fairly quickly as the squaring function that's been shifted. So for part A, the basic graph is the squaring graph, y equal to x squared. Part B says describe the shift. Well, again, we know that the squaring function would normally have the vertex at 0, 0. It's been shifted 3 units to the right. As a result, then, when we're trying to write the function down, remember, we'll take this y equal to x squared. Since it's a horizontal shift, something happens before, right, because it's moving horizontally, something happens before we square it. Okay, so remember, 3 is where the vertex is now. So 3 sort of acting as our new 0. So remember, that becomes x minus 3 quantity squared. Okay. Second one here is, again, you should be able to recognize this fairly quickly as the absolute value function with a shift. Okay. Again, similarly to the squaring function, the corner of the absolute value function is typically at 0, 0. So in this case, it's been moved 2 units left and 1 unit down. So the shift 2 units left and 1 unit down. Okay, so how do we write this function? Well, again, there's 2 shifts. The horizontal one happens before you do the absolute value, and then we'll have the one outside. Okay, so we went 2 units to the left. So again, our negative 2 is our new 0. So that makes it x plus 2. And then 1 unit down is outside of minus 1. Okay. A couple more of these types of questions. So again, this graph you should recognize as the cube root function. It's shifted up here. It's not real easy to see, but it's shifted up 1 unit. Okay. So again, when it's a vertical shift, it happens after you cube root. So it's up 1, so that's a plus 1. And then the last one here you see is the square root function moved over. So again, we're used to the square root function starting at 0, 0. So this is moved 2 to the right and 3 units down. Okay. So shift 2 units right and 3 units down. Okay, so again, there's 2 shifts. One will happen inside the square root, one will happen outside. Horizontal is the inside, would happen to x. So when we went right 2, remember 2 is acting as your new 0, so that's x minus 2. And then outside is a down 3. Okay, so this is when we're given the graph of the function. Okay. All right, the next couple, we have a graph. We're just going to call it f of x. Okay, it's not one of our 9 famous functions. Okay, so we could still do shifts on this. Okay, for graphs like this, I usually like to just make a table of values and see what happens to the table of values. Okay, once you have the table for the original, we'll create new tables for the other ones, plot the points, and then we'll be able to create a new graph. Okay. So again, I just picked a few key points here: negative 4, 0, negative 2, 2, 0, 2, 2, 1, 4, 0, and 6, negative 1. Okay. So I'm just going to watch where those points move. Okay. All right, so the first one we have here, so we get this straightened out here, is y equal to f of x minus 3. Okay, so again, this is a shift happening inside the function, so it's horizontal. So this will shift, remember, minus 3 means right 3 units. Okay, so when you're looking at this one, when you're gonna go right 3 units, it changes all your axes, right? And you're moving horizontally, it's gonna move it to the right 3 units. So all these axes move right 3 units. So our new table is here. Nothing will happen to the y, so it's still 0, 2, 2, 1, 0, negative 1. Okay. But all the x's go right 3 units. So instead of at negative 4, it goes right 3 units to negative 1. 1, 0 goes over to 3, 2 goes to 5, and so on. So once we have those points, we just have to graph those. Negative 1, 0, 1, 2, 3, 2, 5, 1, 7, 0, and 9, negative 1. The original is all connected with straight lines, so a similar thing will happen here. Okay, and you should be able to see that it just moved everything right 3 units. Okay, but again, I'd like to use the table. Second one, clearly there's 2 shifts here. Okay, so remember there's an inside shift and an outside. Inside is horizontal, so the +1 moved it left 1 unit, and the outside is up 2 units. Okay. So clearly we're going to change x and y. Now again, we're looking at the original function. So our new table, since there's 2 shifts, a horizontal and a vertical, both x and y's will change. Okay, so again, left 1 unit moves all these left or down, or to the, decreases it by 1. So this go back to negative 5, negative 3, negative 1, 1, 3, 5. Okay. The y's all go up 2. So this is 2, 4, 4, 3, 2, 1. Okay. And again, to just do the graph, we just plot all those points. Negative 5, 2, negative 3, 4, 1, 4, 1, 3, 3, 2, 5, 1. Okay. So just another way to look at some of these shifts using tables.